Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2018. This is question number 4 from paper 1. This is from the topic Lagrange's mean value theorem, one very important topic. In fact, this is one of the trickiest question of 2018 paper. Let us see what this question is. For every twice differentiable function f r2 minus 2 comma 2 with f0 whole square plus f dash 0 whole square is equal to 85, which of the following statements is r true? A. There exists r comma s belongs to r where r less than s such that f is 1 1 on open interval r comma s. B. There exists x naught belongs to minus 4 comma 0 such that mod of f dash x naught less than or equal to 1. C. Limit x approaches to infinite fx is equal to 1. D. There exists alpha belongs to minus 4 comma 4 such that f alpha plus f double dash alpha is equal to 0 and f dash alpha is not equal to 0. Now let us start with option A. It says there exists r comma s so that in open interval r comma s f is 1 1. I think this is a direct consequence or direct observation for any function which is not constant throughout, because if it is not constant it will be increasing sometimes, it will be decreasing sometimes. So I can choose r comma s in its domain so that it will be increasing only or it will be decreasing only in that open interval. So this function will be 1 1 in that interval. Now for this function we are given this relation and also we are given that its codomain is from minus 2 to 2, which means f0 whole square cannot exceed 4. It has to be less than or equal to 4. And from this relation then we can say f dash 0 whole square will be greater than or equal to 81, because then only this sum will be 85. Hence I can say that f dash 0 will not be equal to 0. So which means this function has at least non-zero derivative at x is equal to 0. So this cannot be constant throughout. So there will be some interval r comma s preferably containing 0 so that this function will be either increasing only or decreasing only. Hence this A option is absolutely correct. Now coming to B part. Now to solve this B part I will use Lagrange's mean value theorem on 0 comma 4. I will use Lagrange's mean value theorem on minus 4 comma 0. Because function is twice differentiable, so it will be differentiable and continuous. So prerequisite for LMVT to be applied is okay. We can write direct its consequence, which is there exists x naught belongs to open interval minus 4 comma 0 so that f dash x naught is equal to f0 minus f of minus 4 upon 0 minus minus 4. So its mod can be written as mod of f0 minus f of minus 4 upon 4. Now because function has codomain from minus 2 to 2, so maximum possible value of fx at any x is 2 and similarly minimum value is minus 2. So difference of any two values of this function cannot exceed 4. So this f dash x naught magnitude can be written as less than or equal to 4 upon 4, which means f dash x naught mod is less than or equal to 1. So the answer, so this option B is also correct. Okay, in fact let me tell you, similar to this we can also say that there will be x1 belongs to 0 comma 4 so that f dash x1 magnitude will be less than or equal to 1. I am going to use this result in its D part. Let us first solve now C part, which says limit x approaches to infinite fx is equal to 1. Now to do this, my argument is that we are given a relation. Now this given relation, cannot fix value of function at any x other than x is equal to 0. Why I am saying so? Even if f0 is fixed, f dash 0 is fixed and function is twice differentiable, we have infinite paths to move my function from x is equal to 0 to other value of x. So this relation cannot fix fx at x not equal to 0. So saying limit x approaches to infinite, fx is equal to 1 is not true. In fact, I can give you one example in which if I take fx is equal to 2 into sine of root 85x upon 2, this will give you f0 to be equal to 0. This will give you f dash 0 to be equal to root 85. So we can see this relation is satisfied, f0 whole square plus f dash 0 whole square is equal to 85. But limit x approaches to infinite, if we find for fx, it will be an oscillating value between minus 2 to 2. So this does not exist. Okay, so saying this C option correct is wrong, or in fact I should say C is wrong. I have already proved that A was correct, B was correct. Now coming to D part. Now to do this D part, I will assume a function g x to be equal to fx whole square plus f dash x whole square. Now the motivation to take this type of function comes, number one, this given relation, and two, in this D option we are given that we have to find that f alpha plus f double dash alpha is equal to 0 and f dash alpha is not equal to 0. If we differentiate this g function, we can find 2 times f dash x into fx plus f double dash x. So what we need to prove? We need to prove that x is equal to alpha. This bracket will be equal to 0 and this f dash x will not be equal to 0. So this will not be equal to 0, this will be equal to 0. Now to prove this, let us understand first that g0 is equal to 85 already. Okay, and if you remember in A part, we proved that for x naught belongs to minus 4 comma 0 and x1 belongs to 0 comma 4, magnitude of f dash x naught will be less than or equal to 1, and similarly magnitude of f dash x1 will also be less than or equal to 1. And already because of this codomain, f x naught magnitude or whole square of this will be less than or equal to 4, and similarly f x1 whole square will be less than or equal to 4. So using these all inequations, I can say that g of x naught, which is f x naught whole square plus f dash x naught whole square, will be less than or equal to 4 plus 1, that is less than or equal to 5. And similar to this, I can also write that g of x1 will be less than or equal to 5. So we have got 3 conditions or 3 values for g function. At 0 it is 85, for x naught it is less than or equal to 5, for x1 it is less than or equal to 5. Now using these 3 conditions, let us make a graph, a simple graph for this function gx. Okay, we know that at 0 the value of this function is 85. So this point is 0 comma 85, you can say. Now 4 here, minus 4 here, so between minus 4 to 0 there is one x naught, and between 0 to 4 there is x1. Okay, now suppose this is a line which represent y is equal to 5. So from these inequations for g of x naught and g of x1, we can say the value at x naught will be starting with this line, or it will be going below from this line, and same goes for value at x1 also. Value will be either 5 or it will be less than 5. In both scenarios, if I take the general scenario in which it is less than 5, we can draw a simple graph like this, and it should pass through this point 0 comma 85, and because it has to come down to 5 or less than 5, this graph have to come back and it should be going to this point. This could have come to y is equal to 5 also. But one thing is now very much clear, that this function while going up and going down, it will have one point of maxima. This maxima could have been at 0 also, but not in general. It can be before 0 also, it can be after 0 also. Let us call this point as alpha. Okay, and at this point alpha we can say that g dash alpha will be equal to 0, and g dash alpha means, please see, it will be 2 times f dash alpha into f alpha plus f double dash alpha is equal to 0. Now at alpha, if I write g of alpha, which will be f alpha whole square plus f dash alpha whole square from our assumption of this function gx. Okay, now because f alpha whole square, because of this codomain condition, will be less than or equal to 4, and g alpha we can see it has to be greater than or equal to 85. If the maximum value was at 0, it can be 85 also. If it is not, then it can be greater than 85 also. So from this again we can say that f dash alpha has to be greater than or equal to 81. In fact, f dash alpha whole square has to be greater than or equal to 81. So this f dash alpha cannot be equal to 0. We can claim from this argument. Now using this equation, which is f dash alpha into f alpha plus f double dash alpha, because this f dash alpha is not equal to 0, because this f dash alpha is not equal to 0, so I can say this f alpha plus f double dash alpha has to be equal to 0. So this D option is also correct, because f alpha plus f double dash alpha is equal to 0 and f dash alpha is not 0. So A, B and D are the correct options for this question. This completes the solution of this question. I hope you like this solution. Thank you so much. Stay tuned for more solutions. Bye.